Jim. I'm a sales engineer for Elasticsearch, and I started about 2 months ago. So I'm fairly new, and you guys are probably more experienced with Elasticsearch than I am. But really excited about what's going on in Philly. I think this is our second one that James has put together. And so, yeah, we're really kind of looking for different ideas to grow this community here. And so if you've got any ideas, just feel free to ping me. You can kind of look, it's just peter.kim@elasticsearch.com. Or you can look me up on LinkedIn. But yeah, just want to thank James and just Indy Hall, I guess, for hosting us. This is a great space, and hopefully we can have more here. Or if you guys work for a company where you might be willing to host a meetup, feel free to let me know, reach out to me, talk to me. I think what else? I think that's it. So yeah, we've got JP from Wildbit, right? Come talk to us about how they're using Elasticsearch.
Hey guys, I'm JP, Toto, like Peter mentioned. I work at Wildbit, which is actually on the 7th floor of this building. We have a couple of products. One's called Deploy, which is for deploying your applications to various servers through SSH or FTP or a couple of different avenues. Postmark, which is the app that I work on, which is an transactional email API, which you should all be using to send your transactional messages, and then Beanstalk, which is for repository hosting and also integrates deployments too. And I'm actually here with Ilya, who's going to be talking tonight too about the Beanstalk side. He's like a founding member of the Beanstalk product. Artem, who works on Postmark with me, and Nick, who's also going to be talking about Elasticsearch, barbecue. And in the back, please introduce yourselves to Britt. She's our community manager and is working to sort of branch out in the city and meet developers and help get a little bit more involved in community projects and things like that. So, is everybody here? Is anybody not familiar with Elasticsearch here, or have used it at all? Or because I'm going to go over some like basic query stuff. All right, good. So we've got some beginners. So what we're going to do is we're going to break this into sort of 3 parts. And I'm going to go over some Elasticsearch basics. I got a bunch of slides. I'm going to go through and just talk about how it differs from regular SQL type database and things like that, and then I'm going to do like a little bit of a demonstration of how you can interact with Elasticsearch to store data and query for it. And then I believe Ilya is going to talk a little bit about how we use it for Beanstalk. And then Nick is going to give a technical demo on his laptop of how to cluster Elasticsearch, which is one of the core strengths of Elasticsearch. So we're going to kind of break this into 3 parts. Please stop us if you have any questions anytime. I'm happy to answer them to the best of our ability about what we're doing. We're not experts on Elasticsearch, but we're trying to push the limits on it and take it to so that we're using it more and more across our products, and we're leaning more heavily on it. So we're forced to become better and better at it. So I'm just going to go through some slides. I'm going to sit because there's not like really a stand up here. So if anybody can't see me or needs me to talk louder, just please raise your hand. Excuse me, it's kind of a small group, so I think we'll be okay. So what is Elasticsearch? It's a NoSQL database. Data is stored as documents and not tables and rows in a database. You can download it at elasticsearch.org. It's a free product. It's built on top of Lucene, which is a searchable search database. So it takes the power of Lucene, and what's essentially done is put clustering and high availability and a REST API on top of it, which I'll demonstrate in a little bit. It runs on Java, so it'll run on anything. We run it on Linux. I'm going to show it to you running on Windows because I was trying to make it run on Mac today, and Java on Mac is a hot freaking mess. It just pisses me off. So we're going to see a Windows demonstration. The REST API kind of takes away some of the complexity of Lucene. If you've ever worked with Lucene before, it can be kind of like a pain in the neck to work with. It's also really super scalable. And Nick's going to demonstrate just like how easy it is to scale. It's one of the core strengths of Elasticsearch. Just to sort of draw some analogs between Elasticsearch and SQL. In SQL, you have a database, and Elasticsearch, that's an index. In SQL, you have a table, and Elasticsearch, that's a type. Likewise for rows, documents, column is a field, a schema, your table schema is a mapping. In database, you specify which things you want to index. In Elasticsearch, everything's indexed by default, unless you change that. Use SQL to query for data in a regular SQL database. You use a special query DSL on Elasticsearch. And then instead of doing selects and updates in SQL, you use HTTP verbs to query from Elasticsearch. It's an extremely RESTful API, so you really just use pure, gets, puts, posts to execute queries against Elasticsearch. So why would you want to use that? So if you were searching in SQL, you might do select star from table, where column is like percent something else, and you try and kind of figure out some fuzzy searches, and that has some limitations because you can't do ranking, you can't customize it for languages. It's just not really built for searching like that. I touched on this, but one of the biggest strengths of Elasticsearch is that you have multiple servers running in a cluster, and it's really, really easy to do that. So when you have multiple, I don't really have an illustration of it, but I can show you in a second. When you put your data into Elasticsearch, it's automatically divided into shards, and those shards are spread across all the nodes on the cluster. So this way, when you have multiple nodes, say you have like 10 nodes in your cluster and one goes away, the shards will automatically migrate to the working nodes. So you get to spread these queries across all these nodes, it spreads out, it distributes the load, and then if you have failure, the data will still be there, migrated over to the other nodes. Elasticsearch also has what's called analysis and different analyzers. I'm not going to go through these point by point, but when I mentioned before, when you do select star from, and you do like, and you're trying to query against, maybe it's error logs or different language or just regular straight out text, you don't have any choices. You're just doing a like and you do select from and whatever. Well, with Elasticsearch, you can put into place different analyzers and say, well, I want to use this analyzer against this kind of data because it's going to work better, and I can change my queries that way. So it's handy to choose different analyzers depending on what data you're using, and you'll get different results from your searches. And you can also build your own analyzer depending on what you're putting in. So at Wildbit, we use Elasticsearch very heavily on Postmark. We index all of our emails in that to make them searchable. So when you're in your activity screen, and I'll show you that in a second, I can search my emails by subject and by recipient. And we're talking about an awful lot, millions and millions of emails. So to do that very quickly and have a bigger, faster search time, we need like a really powerful search engine. And Elasticsearch gives that to us. So just to give you an idea, we have 4 Elasticsearch hardware data servers, and then 1 virtual machine that sits in the front of those and sort of divvies out the queries across those servers. But that's it, it's just 4 servers for all those millions of emails. And then Beanstalk I intentionally left blank because I'm going to let Ilya talk about that. So who else uses Elasticsearch? GitHub uses it for code search. Stack Overflow uses it for really fast searching. Foursquare. And there's a WordPress blog, I forgot to include the link. There's a guy that works at WordPress, and they've converted fully over to Elasticsearch, and he's really into the DevOps side of it. Has a lot of really good tips. I'll post that link in the meetup group because he's got a good blog. So one thing I wanted to do is show you how here. Okay. So what I'm looking at here is it's the Postman plugin for Chrome. All it does is send HTTP requests to wherever you want. I use it a lot for testing. Postmark is a transactional email API, so I do a lot of API testing. I have Elasticsearch installed here locally. I'm just using Java version 7 and just plain old Elasticsearch, which is downloaded and installed using that MSI file. So one thing you can do to verify your Elasticsearch installation is just do a GET request against the server, and Elasticsearch by default runs on port 9200. So here we can see, can you guys see that okay? Yep, sort of. All right. So you can see here, it returns a JSON response, running version 1.0. I believe 1.2.2 was released this morning. We're running 0. something in production with plans to upgrade it very soon. The timestamp for the build, and then always their tagline, for search. So this is a good way to sort of verify that if you've installed Elasticsearch, that it's running okay. I've also got a, oops, I don't need to see my email. This is a plugin that I've installed with Elasticsearch called Head, and it gives me an overview of the Elasticsearch cluster if I point it at the cluster. Right now you just see my little node, it's called Toto Node 01. There's no indices here right now. It's really just a plain vanilla setup. I can go to this info tab and see the same data I just queried from Postman. It's just some status on what Elasticsearch is doing. So if I go back, and now let's say I want to create an index. I want to go over this real quick here. This is I'm doing an HTTP post. I'm going to call it the people index. This is going to be my new database. Now I'm going to pass in a JSON document here with some interesting stuff here. There's a settings section. I'm telling it how many shards I want to create, how many shards across this cluster do I want to split my data across, how many replicas, those are backup shards. I'm going to do 0 right now. And then the mappings are like my schema. I want to have a person type, and these are all the properties for the person. I want a first name, a last name, an age, sex, message, and timestamp. So if I post that to my index, scroll down, I get an acknowledged true, I get a 200 OK. And if I go back and connect to my index, connect to my server, I can see each of these are a shard. So it created the people index, and it created the 5 shards like I asked it to. Now there's no documents in here, there's no data. So how do I get data into here? Well, scroll back up here, let's see what's going on. So I can insert a person that matches that schema. You don't have to create your schema ahead of time, but if you don't and you just start sending data out of Elasticsearch, it's going to do the best it can to guess at your schema, and you may get some undesirable results. So I would recommend that you create your schema and pick the properties for your data each time. I didn't go over some of the extra properties you can put on. There's tons of great information in Elasticsearch docs, but you can set those properties to be analyzed a certain way, pick the analyzer for it. You can choose them to be indexed or not, or just ignored by Elasticsearch. For now, we're just going to index everything. So if I use I'm posting an HTTP post to the person type in the people index. So pretend this is the people database and the person table. And this is the data I'm going to post in, this JSON document. First name, last name, age, and some other good stuff. So I can post that in, and it'll return, I wish I could make this one up here, I can't get to it. Returns the ID that it created for me on the fly, the version, because Elasticsearch will version your documents, and created OK2, 201 created response, so we know that worked okay. I'm going to go ahead and insert 3 more people with similar data. And just so you can see them, we can actually browse that data. Now you can see we have 4 documents here. If I go to the browser, I can see I have 4 documents. If I click on one of them, I can see the actual data inside of Elasticsearch. It'll show the version, the first name, last name, all your regular data. So now we've got data in there, but we want to see how to query for it. Why is this interesting to us? So one basic query is called the query string. And this is how you compose a query in Elasticsearch. You would, oops, get that back. I append _search onto the type I want to search for. You could also put that at the end here instead of person if you want to search across multiple different types. And then in my JSON document, I'm telling it I want to do a query. This is the type of query. It's a query string query. The field I want to search on is message, and this is my actual text query. So if I execute that, go down, it'll show me the 2 people that I returned. Here we can see both of the people. Now it returned the JP person because that message is the quick brown fox, and it also returned the Kevin person because the message is the quick brown fox jumped. So you can see one behavior of this query is that it's all these characters or tokens in Elasticsearch, and it matched with an OR. It said, if you match any of these, any of this string, return that document. Now, a different query, if I used a match phrase query, and I use the same query text, but I tell the operator I want it to be an AND query, I want it to match every single one of those tokens, and I execute the search, now it just only returns the Kevin person because it only has that specific text in the message. Other things that are interesting about these query results is you can see the hits. It returned one user or one document. It gives you the score. I'm not really going to get into the score tonight, but it gives you some extra meta information on your search that may or may not be useful. Like you might just want the count of the document, so you can pick that right off of the hits. Now, another interesting query type you can do are facet search. So this is what's called a statistical facet. I can run this type of query. It's a facet. I'm going to do it on the age field, and I'm going to say I want a statistical facet based on the age. And if I run that, it'll return. I'm returning all the documents, but then down here on the bottom, I've got a breakdown of the statistics for all those documents based on that age field. So there's 4 documents. The total of all the ages is 120. The minimum was 25. The maximum was 38. The mean of those is 30. You got the sum of your squares, the variance, all kinds of interesting things like for free, right built into the statistical facet search. There's a histogram search, which is kind of similar. I'll do that on the age field as well. And what that'll show us is there's 2 people aged 25, there's 1 person aged 32, there's 1 person aged 38. You can see the count based on on the number of documents that fit into that. This is returning really quickly because I only have 4 documents, but if I did this like on our production Postmark database, it would return almost as fast. It's really, really quick at it. And I also have the term facet search. So if I go, if I use the last name field and just give me a facet on the terms on that field, like it's almost like a group by in SQL, and I execute that search, there's 2 people named Toto, there's 1 person named Smith, and then 1 person named Jones. Now similarly, if I wanted to delete an index, I just type in the URL, it's an HTTP delete, and if I execute that, it'll say acknowledge true, 200 OK, and if I go back to my index, it'll be gone, because it just executed a delete. I know that was kind of quick, that was kind of a whirlwind tour of just how you can interact with Elasticsearch, but I want to leave enough time for everybody else to go through. Nick's got some really interesting things. Just real quick, I want to wrap up with how it compares to some other search databases that are popular. So Elasticsearch versus Solr, also built on Lucene. It's good if you're just doing one server, but you don't really get that clustering that Elasticsearch has. And Nick's going to show you that how easy it is to cluster Elasticsearch and make it stronger. You don't get that with Solr. There's also lots of different branches of Solr, so you kind of have to pick and choose which one you want. It may or may not be maintained really well to get the features that you want. Sphinx is another popular choice, also good for single server searches, but no out-of-the-box clustering again. And lacks some of the features that Lucene has, like some of the statistical and facet searches and things like that, that the ES has for free. So how we use it at Postmark is we actually have it linked to CouchDB. We store our messages in CouchDB, and we use a plugin that's called River. So the Elasticsearch River plugin connects to Couch, and anything that happens in Couch, that transaction log is automatically fed over to Elasticsearch in the River. So if we add a document in Couch, it automatically shows up in Elasticsearch. If we delete it, it deletes from Elasticsearch, and so on and so on. So we have like sort of a system of record in Couch, and then whatever happens there gets migrated over to Elasticsearch, and we do the searching on Elasticsearch because it's really good at searching. So we have sort of like 2 databases that we maintain there, but it's a popular setup. A lot of people use these rivers There's a good river for MongoDB. There's even some SQL rivers. It's a good way to get your data reliably into Elasticsearch so you can search it really fast. Finally, should you put everything into Elasticsearch? Probably not. I mean, you don't have to, and we don't. Like all our account management, like users and their names and addresses and things like that, and the what servers they have on Postmark and things like that, account information we have in MySQL because it lends itself to that kind of database. It's just a regular relational database. But all our messages, I might send, as a big user, I might send thousands of emails every day, and that's not as practical to store in something like MySQL, so we store that in Elasticsearch. And that seems to work really well for us. Should you use it as a primary data store? Elasticsearch is past 1.0 now, and it's gotten snapshot support and a couple of other really key features. If you ask Shay, who started Elasticsearch, we'll probably wave you off of using it as a primary data store. Depending on how important your data is, you can probably get away with it, especially with the snapshots and backups that it has. So, if you're talking about transient data that is like logs or something like that, perfectly safe for that. If it's really important information you can't possibly lose or rebuild, you might want to make sure you have like a really good operations set up in place so that if something goes bad, you can restore that data from a snapshot really easily. I'm going to turn it over to Ilya now so that he can talk about how Beanstalk uses Elasticsearch.
All right, so we used to use Sphinx. We used to use Sphinx and Beanstalk, and the idea was to index every single commit that comes into Beanstalk and make it searchable. That was I implemented it many years ago overnight. Basically, we didn't have any search at all in Beanstalk, and I figured like it would be nice to have search. So Sphinx seems to be a nice solution. There was a nice plugin for Rails. Thinking Sphinx or something like this. So I plugged in Sphinx and it served as well for some time. And, now delta indexing was kind of a pain in the ass, especially back in the days. I think they did something to it, but when we just started, I just re-indexed the whole thing every X months. It was not a real-time system, so I had a cron task to re-index the whole damn thing. But the good thing is Sphinx is super fast with re-indexing. It would re-index gigabytes of data in like no time, less than a minute. So that worked well. And then we started getting complaints from customers that commit doesn't show up. They commit, they have to wait X minutes before the commit shows up. And then the data set started drawing, so we couldn't re-index as quickly anymore. And it actually would take 10 minutes, 5 minutes, more time, 15 minutes. And my brother, who also works at Beanstalk, said that it's all a piece of crap. Overnight, he scrapped Sphinx completely out of Beanstalk. He implemented Elasticsearch. We had a big discussion about it. Do we need another technology? Beanstalk. It's another thing to maintain, another thing to understand. Nope. Postmark guys used Elasticsearch at this point, and we knew they liked it. And so Dima implemented Elasticsearch, and we now use it, and we're very happy with it. And it was a very nice transition from Sphinx. We no longer have any problems with the indexing. Right now it's implemented as a real-time system, so every time it comes in, we index it separately. We do not re-index any stuff anymore with the cron tab, and I don't recommend that. I wanted to show you some of the ways we use Elasticsearch in Beanstalk, because I think we found unusual use for it. You will judge. First of all, we have, of course, commit search, which is a full text search, nothing fancy. This is a Rails repository here. We played a little bit with a code search, and it's a secret project, so don't tell anyone. We'll have to destroy the tape after this. Dima was actually working on code search for Beanstalk, and the idea was to put basically the contents of all the repositories, and it's terabytes of data, into Elasticsearch. And we played with it we did many variations, because you can put every revision of every file. But then if you have terabytes of repositories, every revision is going to be more. And it was a lot of data. So then we played with putting like diffs of files and then trying to construct revisions based on that. And that worked well. But it still required us to have a cabinet full of Elasticsearch servers. So we put that on hold. But it worked great. Like Elasticsearch-wise, it scaled really well for that. So, what I want to show you is a more interesting thing. I don't know if you guys use Beanstalk or not. You definitely should. We have this thing called reference selector. It's featured in many pages, and it allows you to select a commit or a branch or a tag for that matter. Right now we are on the file page, for example, and we wanted a quick way for you to select different revisions of the file. We also wanted to give you a way to select different, to see that file, how it looks in different branches. And you can imagine the amount of revisions we have, the amount of files we have, and you can imagine the challenge of trying to determine real time, for example, all of the branches in which this file exists without hitting the disk. But you can't actually go to the repository to check that stuff. And this is where Elasticsearch surprisingly worked for that stuff. And at first it was an experiment. I was looking for a solution to implement that, and then I looked into Elasticsearch, and it already had all the information we need, because every commit goes to Elasticsearch. The way this works is, and it's pretty awesome. This file, for example, it's a file from a Ruby on Rails repository. If you click on branches, we only show you branches in which this file exists. So if you have 30 branches, sometimes it's hard to, you have a file, for example, you're doing code review process, for example. You want to see where this file exists. Was it merged into a specific branch or not? This page, like this tab in the reference selector, shows you that this file exists in only these two branches. You can switch between them easily. You can also see all of the commits that belong just to this file. Only 12 commits change this file ever in the history of the repository. You don't see the old commits. For that, we have a hamburger icon here, which nobody understands what it does. It's the most confusing UI element of all this stuff. If you click on it, you actually see all of the commits that the repository has, 53,000 commits, and all of the branches that the repository has. You can switch between them. But switching to this mode, it only shows you stuff that's relevant to this specific file. It does it very quickly, and it's a real-time lookup. And it's all made in Elasticsearch, and I will tell you in a second how it's actually made. You can, of course, search for commits. So if you switch to commits, you can search for commits. You can search for commits in a specific branch. You can search for commits by a specific user using account. And that stuff is really awesome because GitHub doesn't have that stuff. And they have a million developers, and they have a million more developers every day, but they don't have that stuff. So I think that's pretty cool.
Are we seeing this is this production, like just the speed there?
This is all production.
That's awesome.
And it's been in production for some time. And it's one of the features of Beanstalk that people don't care about. When we launched it, me and Eugene worked on it for a couple of months, and we were so excited about it because it gives you all of these possibilities. You can, for example, you could quickly see if this file was ever merged to staging or not. You could just go to that file and open branches tab, and you can see if it was not merged to staging. It doesn't exist in staging, just by looking at this thing. And people hate it. Oh, people don't hate it. I don't think anyone actually ever gave any comments about it. This is the way. I don't know if I'm supposed to show you this stuff, but if anyone asks, I didn't show you this. That's the commit document in Elasticsearch. And I just want to explain to you how exactly. For example, when we look at this file, we want to find all of the branches that this file exists in. We do a search with a prefix filter in Elasticsearch. And Elasticsearch has a prefix filter that works really well for file paths, surprisingly. And we have, each commit object has a list of changed files within an array, which is an array. And Elasticsearch allows you to store arrays as first-class citizens. You don't have to serialize them to YAML. You actually store an array. And you can search that array as a first-class citizen. And we use the prefix filter to find all of the commits that, for example, have this file, this specific file in the changed files array. And it just gives you that. And from there, we use, to get branches, we actually use facets. Because we don't need, like at this specific place, we don't need a list of all commits where this file was changed. We need a list of branches. For that, we use facets. So we get all of these commits, and then we create a facet based on the branches field, and it just gives you branches. It works like magic. It's only a couple queries, and Elasticsearch does all of it, and it gives you all of that information, and it's pretty freaking fast. And we don't hit disk at all. Like at this point, the repository may not even exist on disk. We wouldn't care. It would just work. So you see, you're not impressed. That just proves the point. People hate that stuff. Another thing, we have the activity stream of commits, and it's using MySQL. It was using MySQL since the Beanstalk was created. Actually, in the beginning, it was using disk, so it was just reading commits from disk. And then we implemented MySQL caching, so it would come from MySQL. We have a lot of problems with it. Every commit object contains a list of files, which is a serialized YAML string. And that MySQL table, you can't imagine. It's gigantic. We have this MySQL table. We can't add indexes to it because it takes forever and it locks the table, so Beanstalk goes down. We can't add or remove columns from it for the same reason. We can't scale it at all because you can't. It's a single table. You can't do anything with it. So we're kind of stuck with it. So the plan was to slowly transition away from it, and Elasticsearch seems like a good option. That's why when we worked on file history, every file has a button called File History. You click on it, you see all of the commits that changed that file in a timeline. It's basically the same activity, but this one uses Elasticsearch. It's not using MySQL anymore. And it works really well. It's really quick, and it's scalable, really easily scalable. Anytime we can throw machines to our Elasticsearch setup. We can add more machines anytime, and it's going to be faster. And it's going to serve more requests. Now I'm just going to say a bunch of numbers too. We have 3 VMs. We don't have hardware in the lab because we're not as cool as Postmark guys. We have a lot of 3 VMs serving AES stuff. Our index is about 100 gigabytes, which is a tiny. We index commits, comments. We have tens of millions of documents. And the features that I just showed you use Elasticsearch. That's how we use it. The reason other feature that I'm not sure if I should tell you. I can't tell you about this feature, but we also use Elasticsearch for a brand new feature that's coming out very soon, and it's going to be a huge part of the future Beanstalk. And we use the child-parent relationship of Elasticsearch. It has this child-parent association of Elasticsearch, when you can associate documents with each other, and then you can say, okay, give me all the children of that document. And that can be, for example, a blog post with many tags. And you can find every blog post with tags or without tags by using the child-parent relationship. And I wanted to, in the future that I'm working on, which I can't tell you about, so it makes this pointless, uses the child-parent relationship and it works well. So the end result of this story is that Elasticsearch is awesome. And that's it. Thank you very much.
Okay, so I'm going to talk a little bit about, kind of show you like how to bring up ES indexes, nodes, and how they cluster, and all that jazz. So I'm going to be building instances using Docker because it's cool. So the dependencies to run an Elasticsearch node are pretty minimal. So like JP said, it runs on Java, so we need Java. And then I'm just pulling down the Elasticsearch tarball, unzip it, and run it. One of the finer points that that JP mentioned was we're running, for Postmark, we have basically like a load balancer node. I don't know what the official term is, and we have data nodes. So it's so the role of the load balancer node is basically it's a member of the cluster, but it doesn't store any data, so it doesn't have to do anything involved with the actual indexing of the data. But because it's a part of the cluster, it knows where all the shards are. So you can feed a request to it, and it knows, okay, I need to go to this node in order to get the data. So that's kind of the role of the load balancing node. So that's how we're using it. part of our Docker file. So we're setting a cluster name, which we're going to call Elasticsearch Docker here. And that's important because by default, it's all the ES clusters are named the same. So, and by default also, it does multicast discovery of other nodes as part of the same cluster name. So you could get a little overlap that you don't want. So keep that in mind.
Yeah, don't do. Always change your cluster.
Yeah. And like JP said, by default, the HTTP part runs on 9200, and 9300 is like the binary format that it talks between nodes. If you're running Java, you can talk the binary format to Elasticsearch, but we most of the time just use HTTP. So we got that, and here's for the Docker file for the load balancer node. So it's pretty much exactly the same, except we add this one little field to the config file, which says don't store any data on this node. So I'm going to run some of that. So, where's that go? So all that did was run the LB node, which will be the node that I'm going to connect to, and it will also run 4 data nodes. So I'm forwarding port 9200 so we can go to the browser for that. And as we see here, we have 4 nodes, or 5 nodes. So the symbols are a little bit weird. The star is the master node. And the hollow symbol is the LB node. So because I went through that fast, I'm going to kill those guys again. So I'm going to spin down the Docker nodes. So no Elasticsearch is available. And we're going to start them up again. And so we should see in a couple of seconds how we can connect to the plugin again. Just a couple of seconds. It's totally going to come up again.
No, it's not coming back.
I'm sure of it. It will. It will. Trust me. So in the meantime, yes. So that time it only brought up, there we go, see? So it takes a little while for the nodes to join together, but that's what they'll do. And so it's just picking random node names for these guys as well. So I'm going to create an Elasticsearch index. I'm not going to put any mappings on it this time because I'm just going to let it do its own thing. So this time I'm going to have 10 shards and 10 replicas. So that's the number of replicas per shard. So 20 shards total. Like JP said, shards is how Elasticsearch partitions the data. So you don't want to have a million. I actually probably run that. So the reason why you want a number of shards is because it gives you room to add nodes and the data scales out. So you don't want to have one shard per node because that puts an upper limit where when you add another machine it's not going to do anything. But each shard does come at a limited cost. So right now we're running 10 shards and 2 replicas each. So it gives you a little bit of data security, and it also gives you the ability to scale out your data nodes. So that's how, so Elasticsearch, so as we see, the one with the hollow circle isn't getting served any data. No shards are stored on this machine, and it kind of partitioned the rest of the shards as we go. So I'm going to spin up another 2 nodes. And we should see these join the cluster and see the data automatically start to, so right now, yeah, this node joined the cluster, but it doesn't have any shards. Elasticsearch is going to automatically move the shards over there to it. And so see, we have the other one, and Elasticsearch will automatically, see, so here's, these shards are in the process of moving. And this is exactly how we bring in new nodes in production. Of course, in production, it takes a lot longer time to move the shards over. But once they join and once the data is a part of the cluster, Elasticsearch will automatically repartition all the shards to be equal. And so, yeah, and it's obviously takes into account, no the primary shard and the replica shard aren't going to be put on the same machine and all that jazz. So, like
How do you decide how many shards you end up putting on?
So, like I said, you definitely want. We kind of. I wasn't there for that. Did we kind of guess?
We guessed.
So
you get a feel for like the performance, and you just add some and see what happens.
Yeah,
Well-
and it depends on your data too, the type of data and how you're going to partition it across the shards. We have a very easy partitioning scheme. We do something called routing, and in Postmark, you have an account, and then you have like 1 to n number of like servers, which is just like a logical separation of your emails. So we separate by shard by server ID, and that makes it like really easily. Makes it really easy. So if you like an easy partitioning scheme like that, it'll help speak to like how many shards you think it makes sense to create. I mean, I'll be honest with you, we have 10 in production, and we have across 4 servers, and that's.
Yeah. So part of it, like I said, it's definitely like, do you have an idea of how many nodes you're going to run and what you're going to grow to? Because you can't add, once an index is created, if you want to add shards or remove replicas or add replicas and whatever, you're going to have to recreate the index. So obviously you want more, probably like 2 number of shards. If number of shards is n, and you want like, I don't know what I'm saying here. You want more shards than servers. So if you're planning on running like a 30 node cluster, you're going to want, like 60 shards. So that way, you're able to store primary and a replica on each node, or something along those lines. I don't know. Do you know if does he have any like official recommendations?
Yeah, so I was just going to say that one other thing to consider, I don't know if you guys are using index aliases.
Yeah.
Okay, so that's another way to kind of get around the problem where you can't change the number of shards per index. You can start out by using an index alias. And it's basically just a logical grouping of indexes underneath it. And so if you figure out your data size is growing larger than what you originally planned for, you can create another index and have index alias point to both indexes. So it's another way to, one way to get around that issue.
Yeah.
Or you could flip from one to the other. You could like build a new index on the side on different servers, or even on the same server.
Just happen like slowly, and then just whenever it's ready.
Whenever it's ready, just flip the index like that. And then
Yeah. I have a little example with aliases, but so we use CouchDB as our sort of like primary store of record, and so we have to migrate data from CouchDB into Elasticsearch in order to be searched. So I'm going to start up a CouchDB node, and we should see that guy. So here we have a CouchDB instance running now. And I'm going to also create a CouchDB database. And this is just some data grabbed from Meetup. So this is just curling into that database, a big nest of JSON that represents, different Meetup groups. So same with Elasticsearch. I haven't set up any mappings. I'm just going to feed CouchDB and then Elasticsearch this entire JSON blob and let it do its thing.
this is going over the river.
Is
not yet.
Is the river pretty bulletproof, or do you ever like do full reindexes?
So yeah, we do. So depending on if there's like yes, we do have to do some full reindexes and like sort of like shit goes down type mode. So different problems that can occur are when if for any reason CouchDB like sequences get messed up or like repeat, and then like the Elasticsearch river isn't able to like recover from them. So I'll get into that in just a moment. So right now we have 200 documents in CouchDB, and we have 0 documents in our Elasticsearch index. So I'm going to create a river here. So the river is basically a special type of index. So it's called _river index, and I'm going to name it Philly DevOps. So I remind myself to check for the CouchDB instance. So what we're going to create the Elasticsearch, this special _river index with a special JSON document that'll tell us, okay, with the information. So CouchDB, like where to find the CouchDB server, what CouchDB database to pull from, and what index, what Elasticsearch index to put the data into. And you can also do cool things here, like this is just like JavaScript scripting, where you can, add, modify a field, or like, do other things as data is flowing in to Elasticsearch. So you're able to do some scripting there if you want to manipulate the data as it goes into Elasticsearch. So I'm going to.
What's an example of that? Like, when would you want to
So
manipulate the data?
for us, we store the full email body and all that jazz in CouchDB, but we don't want to store that in Elasticsearch. So we basically null out the full email body part of the document. So that way we only have a little JSON document going into Elasticsearch from CouchDB.
Excellent question.
So right now I'm finding out the IP address of my CouchDB Docker instance. No. Alright, and now I will create the river. And so we got a little error there because in the script I deleted first and recreate it. So now, yeah, we have this new index type, and you see documents are already flowing into our Elasticsearch index. So this method isn't, it's definitely not as fast as it could be. We haven't really investigated where the holdup is in that, whether it's the CouchDB part being slow, or the fact it's just running on a single Elasticsearch index, the actual river part that's taking documents and writing, that's only working on a single Elasticsearch node. But it suits our purpose. It's pretty quick. So this is just running on my MacBook, and that fills up pretty quick. And so we have all 200 documents that are in CouchDB in our Elasticsearch index, and we can do that again. So this is putting data into CouchDB, so just CouchDB, and we should see it flow automatically over into Elasticsearch. So that's how we get our data into Elasticsearch using the CouchDB river. And the part of the CouchDB, it's called the changes feed. That's what this is pulling from. So this will pull over any updates, any deletes, or anything that happens to the CouchDB instance is automatically flowed over into Elasticsearch. And you can see here, or maybe not. I don't know why this page isn't working. All right, there we go. And the alias field. So here I'm going to create, or not. So I'm going to create a second Elasticsearch index here. And so right now, what Peter was saying is that you can use Elasticsearch as an alias functionality that you can use to so that you can point at. So that way it's isolated from the underlying Elasticsearch index. So it has a couple of pretty cool properties. So I can create an index on this, I can create an alias on this index, and I can move it around, I can add it to this index as well, so anything that's searching under this alias will search both indexes simultaneously. And all the operations so this one, so how do you modify an alias? So I'm just gonna pass this JSON document, so I'm gonna remove it from the one index, and I'm going to add it to the other index. And these are atomic operations. So if anything fails, it'll leave it alone. So that way you don't get into a weird state where the alias is actually deleted and your searches aren't returning any results now. So I can do this. And so now we can see that the index is moved over atomically to the other index. And so you can use that to, either flip over if you're re-indexing something, or you can spread it across 2 indices as well. So I think those are all the demos that I have. As far as like caveats that we've had working with Elasticsearch, like we said, like choosing your shard number is like it's kind of a big deal, but like I said, it's stuff you can work around. But it would cause like a reindex, and so that's kind of like the biggest thing. You still have to think about your data a little bit up front if you don't want a reindex. So things that will cause a reindex, if you want to change the routing key. So the routing key determines how data is partitioned to the shards. If you want to change that, you're going to have to reindex. If you want to change any of your mapping fields, like if you have like a string field that you want to be an integer, or an IP address, or a datetime or something, you can't change a mapping. You'd have to create a new index. You can add new mappings that you can do to an existing index. So let's say you're introducing a new field to your JSON document or whatever, and you want it mapped in a special way. You want to make sure you add that field to Elasticsearch before the data gets in there. Because once the data gets in there, it's going to be whatever the default type is, and you're going to have to reindex if you want to change that.
When was the last time you guys re-indexed?
So I forgot to mention that. Yeah. So so we've been pretty careful recently. Like I said, the last cause of our re-index was due to the river failing. And so because like the ID sequences got messed up and we just couldn't restart it. Since then we've been digging more into the river functionality, and we're able to stop that. So the river index, like you see here, it's kind of like has meta information, it has status. So there's the meta information, and it also has a sequence number here. So we've been like logging out all of our like index numbers or whatever. So if something goes wrong with our CouchDB cluster, we know like sort of like the last index number where it's good, and so we're able to, because this is just like documents underneath it, we just recreate the river, the part that does the data flow, with a sequence number that we know is good, and then it's able to like restart from there, the re-indexing process. So that's kind of been the main cause of our re-indexing woes.
I'm going to re-index Beanstalk now when I launch the thing, because I changed routing.
Yeah.
I'm going to re-index the whole thing. So
How long will that take?
It will probably take 2 days, a full day maybe.
Okay.
Yeah, ours, last time we re-indexed, it was at least a couple of days for all the Postmark messages. We have a little bit of an unusual setup because our couch setup is a 4-node cluster, and it's Big Couch, and it's Cloud manages it, and they kind of own Big Couch. And there's a bug where if the node fails over to another active node, it like rolled the last sequence back to 0, and that's what messes up. But if you've got like a regular couch install, you're probably not going to have that kind of issue.
Yeah, and again, that's more of like the river, like the piece in between the two that's failing. Like each piece, like individually, has been like working great, but obviously it's always like the connector pieces that break. So that's been our main cause of.
So when you re-index, you create like a whole other Sudoku board out there, like on the side, and you just let it go, do its thing.
Yeah.
And you can pick it up if it like messes up or something, where it left off. And then you just swap it out with an alias, like you have it pointing at an alias.
Yep.
Yeah, and a practice that a lot of people do is they'll create like an index per week or an index per day, modify the alias to work across those indices, and then they'll set a limit. Well, they'll like delete it at the end of the month. If they have this transient data, they don't need it anymore, and that keeps your indexes fresh.
Yeah, we were looking at what is it, Marvel, like Elasticsearch has like a monitoring plugin or whatever, so where you can put like all your logs in. And so yeah, it creates like an index per day, and then you can put an alias across that. And so let's say you're in an instance where, okay, I only want the last 30 days of logs. That makes it real easy to delete the last 30 days, so that way you only keep like 30 indexes at once.
Yeah.
And so there's a lot of cool use cases that you can use for that, using aliases and the fact that you can like search across them.
Yeah, we were trying to solve, we are spoiled on that too, because we wanted to solve a different problem we're having with Couch using the same technique, and it doesn't support aliases, and there's no way to look across two different couch databases at the same time, and we were just stymied every time we wanted to do something like that. In Couch, that we know we can do with Elasticsearch.
So Postmark has a like 30-day retention limit?
It's our retention day is 45 days
Okay.
for messages.
Did you have to do anything on the couch side of the river, or is it entirely just?
No, we didn't do a thing. You configure like that in Nick's demo. You just give the river the call, the configuration, like the IP and the login and everything like that, and it just starts. It just reads the standard Couch. The underscore changes feed is basically a transaction log of everything that's happening in Couch, and it just reads that as like the slurp.
So this is like
It's sending like the raw.
yeah. So this is like a built-in feature to CouchDB that you have like this changes feed, like JP. It's kind of like a transaction feed, and so it's just able to pull from that. And there's a flag that you can give it to give the full document, but I forget what that is. So.
You mentioned that you're going to upgrade to the new 1.x of Elasticsearch. Have you played yet with the aggregations and are you moving away from facets?
Have you played with Artem? Aggregations and
Yeah.
Artem has played with it. I have not personally played with it, but I know that you're hot too.
If you're asking about aggregations, so as far as I understand, Elasticsearch is going to duplicate existing Facet Search capabilities to replace them with more powerful aggregations framework, which supports multi-level aggregations and it has its own semantics. It's pretty powerful.
Yeah, so that's one of the limits of facets right now. It's like it's awesome that like compared to other NoSQL technologies, you can just do like ad hoc querying like that, but you can only do one level of aggregation. So you can't do like a group by this and this. You can only do a group by one thing to get the facet. So that's one of the benefits of the 1.x releases.
It's a newer version of Lucene too. I think it's like a lot. I saw a chart that Shay tweeted. It was like twice as fast or something like that on that.
If you guys had like 2 or 3 things to suggest to people, just like things that you wish somebody told you when you first started working with Elasticsearch, what would they be?
Definitely the mappings thing.
Yeah.
Like if you want to change a mapping, or like if you're introducing new data, like to do think about your mappings ahead of time because.
Yeah.
Maybe one thing that I still don't quite understand with Elasticsearch, that filtered Elasticsearch has queries, filters, and a filtered query. So for some reason, filtered query is way faster than both filters and queries. So if you have, especially if you have like query and filter, you should use filtered query. Those semantics are not really straightforward.
Yeah, there's also facet filter and filter facets, two different things. And
Also, make sure each node is running the exact same version of Java, like the exact same version.
yeah, that's another thing we've had issues that we run in a new node with a slightly different like minor version of Java, and then we've got like serialization exceptions all over the place. So.
Yeah, and if possible, don't use REST API, use native protocol. Because serialization is expensive.
I have a ton of questions. I will keep asking them.
Please fire away.
But what's the minimum machine that you guys would recommend just running a single?
For production or for like just knocking around?
I'd say
or-
production.
For production, I mean, we used to, before we got the hardware servers, we ran it on virtual machines that had like a couple of gigs of RAM and a couple of CPUs, and it was like 3 or 4 node cluster, and that's running like balls out. Like we process millions and millions of emails every day, and it's doing a lot of work. As long as it depends on the data that you're putting into it and how much usage it's getting. You might have to like experiment a little bit with your usage on the machine that you're using, as far as how much RAM Java's taking up. I would not give that machine any other jobs to do. Like I would have it dedicated Elasticsearch node. If Java's running comfortably and you have enough disk space, that's a caveat. I have Java's running comfortably.
Yeah.
I was going to say, we've been scaling out to Amazon Web Services as
Yeah.
well for
getting our Elasticsearch over in that so it's more scalable and bring it up during the holidays and things like that.
Yeah, and then the only other thing, you know, when you're doing like node revisiting to keep in mind is the fact like, you know, depending on how many replicas you have, that's data set times, you know, and so, depending on if you're just having like big documents, small documents, or what have you.
Yeah, if you have, like Nick said, we have one, in production we have one replica set, so the disk space we use is double the actual, what the documents actually are. If you do 2 replica sets, it's triple, and so on and so on.
So, scenario, you find out, like today, you go back and you realize nothing has been indexed today. What's your workflow? Like how do you handle that problem?
Indexed today?
Nothing's been indexed today, you realize search is not, people are searching for stuff that happened today.
What do you use it against?
Sphinx.
Yes, I understand that. That sounds familiar.
Yeah.
You're just not going to have that problem, most likely. Most likely, you're not going to have that.
Okay.
Yeah, but I think we were maximum 2 hours behind. That was the worst case.
Yeah, but you also have the rivers. Like in your case, you would probably check the river, right?
Yeah.
We haven't had a case where like data was in Elasticsearch and it wasn't.
Yes.
So to speak a little bit about that, it's Elasticsearch is not 100% real time. It's pretty real time. So if you're just using like the Elasticsearch like REST API, like JP said, Elasticsearch is actually like 2 databases. So one is like the document store itself, and one is the search index part. And so the document store itself is consistent in like the CAP sense. So you can like read your own writes and all that stuff. The search part of it is not consistent. It's pretty fast, and we like you said, we have not had issues of where we write a document into Elasticsearch and we're not able to search it like within, I don't know, like a second or something like that. I don't think we've actually timed it, but it's like basically instant, even running on like, you know, commodity hardware.
The only time that's actually come up is our unit tests, or our integration tests. Because if I run our unit tests on my laptop, it writes the document to Elasticsearch, to CouchDB, and then it expects it to be in Elasticsearch, and we're talking like, microseconds later that it inserts a document and then the test asserts and it's not there. And so we have like all these artificial breaks in there that like, okay, let it get the reverse index and flush, and that'll be in there. But we actually have to slow it down just so it passes. It's good problem. Haven't had that kind of failure.
So the default refresh rate is, I think, 1 second.
Yeah.
So instead of maybe wait 1 second.
Yeah.
But you can change that if you need it faster. I mean, it's going to have side effects, right? But
Yeah.
you can reduce that.
Yeah, and it's actually pretty interesting. I was looking so Elasticsearch has some like bulk document features. Like so, if you're putting documents into Elasticsearch like in a bulk way, you can actually control. So you can control the refresh rate at like a configuration level, and you can also change it at a per request level. If you want it like you have like a special case where you want that to be indexed right away, you can set that at a per request level. We haven't messed with that really, but.
I just want you to go away from
Any more questions?
right? Because you don't look closely here.
How
Thanks.
elastic is Elasticsearch?
Very elastic.
It's elastic Beanstalk.
Don't stop. Yeah, don't stop.
All right.
Damn that one.
Thank you guys very much.